Bob with Laguna Tools. I've got a pretty interesting demonstration to show you today. I think we're going to make a Les Paul style guitar body on an IQ with a handheld control. Let's look at some of the features on the IQ HHC. HHC means handheld control, and that's the control that we use for it. These IQs have 3 horsepower liquid cool spindles. Now you say, why do we do liquid cool? Well, sometimes we do very, very long 3D programs, 4 or 5 hours, and that liquid cooling keeps the bearings cool, so you can virtually run these forever. Now this is a dust collector shroud, right? And we've just added a new feature to that, and that is a door that opens up. So you don't have to unhook that to take that off and put tools on. But I tell you a feature I really like about this spindle. It's 3 horsepower is fine, but it holds 1/2-inch tools. So it uses a standard ER32 collet, and that has a capacity for a 1/2-inch tool. So now we can use big tools. The Les Paul style guitar is a fairly sophisticated setup. So what I did on the machine is I took off some of the MDF tables that we put on there, and I created what I call a fixture board, and this is actually taped to the surface with double stick tape. This is used to help me position parts, and you'll notice in some of the setups I use steel pins, and you'll see why in a minute. Well, you know, a couple years ago we did a guitar video, and it's been really popular. Absolutely tens of thousands of people have viewed it, and I've always wanted to do another one. And at the time we did one on a Stratocaster style guitar, but I wanted to do a different style this time. Since that time, we've introduced IQ machines, and they have a work envelope that makes a lot of sense for the size of a guitar. So I'm really excited to be able to do that. Okay, let me explain to you where this all started. What you see on the screen is a 3D model of this guitar. It's a Les Paul style is what we call it. And that was probably designed in SolidWorks because if you notice it's standing up, and Y is up in SolidWorks, which is a little bit different, but it doesn't really matter. This one is a NURBS model, and the extension on it is IGES. You probably want to stay away from meshes like STLs because you can't really manipulate them much. You can tool path them, but you can't do very much manipulation. So that's where this started. Now, once I got that original model, I started removing things I didn't want to produce. For instance, I don't want to make a neck on this video. I want to make a guitar body. So what you see on the screen here is really the body. And there's several parts to it. So for instance, if you notice this, I've got it in ghost view so you can see the internal stuff, but there's actually a top. Oops, let's get that. There's actually a top that's removable. So the first thing we're going to do is we're going to make this part. And if you look at it carefully, it's got machining on the bottom side. It's also got machining up here that's pocketed. And so we pretty much have to do that. Then when you view the top, you see the top is a panel that's glued on there after that base piece is made, and then the final machining here is done. So this is quite a project to undertake. Now let's take a look at how we approach making something like this. The software I'm using is Rhino 5. I'm actually going to do the tool pathing in Aspire, but Rhino 5 gives me a great way to manipulate stuff. So when I bring this out, the first thing I have to get a handle on what size things are. So let's turn this off. It's on a layer. So basically this is the body, or what I call the base, and that's where we want to start. So what I'm going to do first is create a bounding box around it, and now all of a sudden that is a rectangular volume that fits into. Now the nice part about that whole bounding box is that bounding box is a constant. So now, even though that's an irregular shaped product, with that bounding box I can actually manipulate it and move it and be consistent on it. Now we're going to get rid of that bounding box and talk about what's involved in machining. This piece that you see here, this is not 3D at all. This is basically a 2D part. I can make this in VCarve Pro. It's what's called 2.5D, and what it really means is it's a shape cut a certain depth, and that's really all this is. So this is a chunk of wood. On the back side, it's got some pockets cut and some passages, and then it's got a round over, and I could do that round over a couple ways. I chose to just buy a small round over bit, take the bearing off and machine that, but there's more than one way to do that. So we know then we're probably going to start out and we're going to machine this back side. We're not going to machine all the way through, we're going to machine about halfway through. So that's going to be our first setup. Then we're going to take this part, turn it upside down, locate it precisely on the table, and we're going to do this other machining. So that basically finishes that part. We won't be able to do this. You can make a setup to do that, but typically we won't worry about that. These two pockets here, we will catch those later from the top. What we primarily have to machine from this side are these passages, that little groove down through there, and that passage. Because that groove has to be in there for wiring once the cap's on it, so we pretty much have to take care of that now. All right, once that's done, then we're going to come over and put the top on it, reposition it, and then the top is a 3D surface. And we're going to actually machine the 3D surface, and then we're going to come back and do these pockets, and it'll be finished. Okay, now let's look at this a little bit. Now, the first thing I'm going to do is let's look at this from the top view, and you kind of see, now this green axis and red axis, that's Y and X, so the center of this thing is pretty much at X0, Y0. Now remember that, because when we go out to the machine, that's how we're going to locate it. So what I ended up doing here is I started out with a bounding box, and then I made a piece larger, and that becomes my blank. So I started with the bounding box to figure out exactly what the minimum size was, and then made a blank. And so that's what you're seeing here. This is actually the piece of material that we used. So that's what I started with a chunk of wood that size, just a little bit thicker, and you'll see why in a minute. Now, something else I have to have is I have to have the geometry for actual tool pathing. So let's turn some stuff on here where you can, or turn it off where you can see it. Okay, this is what I really need. Now, here's what this is. This line right here, and we'll look at it from the top view. This line represents a perimeter of the blank. So somewhere on the machine, I have to figure out where I'm going to locate the blank to start with. Okay, these two holes here are pins. So, because remember, when you cut one side and you flip it to cut the other side, you have to have some way to get that lined up, or you got a mess. Okay, so that's what those are. And then this is the outside of the shape of the guitar body, and these are those pockets that you saw on the underside. So this is really all I need for this first setup for a spire. Now let's look at how this is done in a spire. Okay, now what you see on the screen here is a setup in a spire. And the first part of this whole project then is to be able to create a setup system so that we can hold the parts down. And here's what I basically did. This piece right here is 22.5 by 24, and I just arbitrarily selected that. It could be bigger or larger, it didn't matter. Remember, the work envelope on the machine is about 24 by 36, so I stayed within that. Now, this is a geometry that you saw earlier that I copied over. So this represents the perimeter of the blank, and these are where those holes for the pins go. So what I wanted to do first was I wanted to really make a shallow pocket across here with a fairly large tool so that this would line up perfectly with the cutter, just like we fly cut a spool board. MDF doesn't work very well with double stick tapes on these heavy parts sometimes, so I wanted a better material. My goal was not to cut through the veneer, to basically just flatten this out. And at the same time, I wanted to drill the two holes, or machine the two holes for the pins, and you'll see how those are going to be used. And then this is really a landing pad over here. I wanted an area that I could use the automatic tool touch off, the puck, that was at exactly the same level as this plane out here. So I thought, well, I'll just machine me a circle pocket the same depth. All right. So, and if you look at the tool paths, here's really what happened. Let's go to simulation, and basically this is that sheet. So this piece is, like I said, is 22.5 by 24, and it's a 1/2 inch thick. It's Baltic birch plywood, so it's real stable. So the first thing that's going to happen is it goes in, and 1.5 inch fly cut tool cuts that pocket out. And if you notice, I put dog bones in the corner so I didn't have to worry about it. Okay. Then I came back in and I drilled pins, and those are the holes there. You got to be careful when you drill pins because you're flipping apart, so you got to make sure that gets mirrored over. And then the last thing I did, we'll go back and reset it. The last thing I did was cut that, because I need to know where the blank goes, because when I start out, I don't use the pin, so I have to know where to tape the blank. So that's what I call the setup file. So we'll look at all those again. So that's where we start. Okay. So now that creates a place for us to start with the blank. We do the machining on the back side. We machine the holes for the pins. Then when we flip it over, the part lines up on pins. That's how we get started. Now let's go over to the machine and we'll look at this setup board. Okay, this is a setup board I showed you on the screen. It's 22.5 wide by about 24 long. I just lined it up flush with the front. It didn't really matter. Then you'll notice it's probably hard to see on the camera, but this was pocketed out, and you can see those little dog bones in the corner. And then there's the perimeter cut, so it shows me where to center the panel, and there's the holes for the pins. So the first thing you make on this whole guitar project is not a guitar at all, it's a setup board so that you can control all the other parts. Okay, let's take this to the next level. Now let's focus on what we do machining wise on what I call the base being the bottom piece. And I did two setups I call base 1 and base 2, base 1 being the bottom side, base 2 being the top side of that base part. And all you really have to have is geometry. If we look over here at the setup, once again the material thickness is 1.75. We're touching off at the table itself, or our fixture. Right. And so then basically all I have to do is do some tool pathing. Now here's what I decided to do first. This is called facing. What I wanted to do first, since the material was a little bit thicker, I wanted to absolutely fly cut that so that it's exactly the right thickness. Now the reason I do that is everything lines up, so then when I put a round over bit to soften an edge, it lines up. So I did that first. Then there's a couple pockets, and those I believe are 0.117 deep. They're not very deep. Those are pockets. Okay, here's pins. There's the holes for the pins. Okay, now this is the outline, and if you notice, this represents the outline of the guitar, and this represents offset from that. So what I wanted to do was just to create a pocket around there, about halfway through. So I believe I set that at an inch deep. Then the last thing I do is I take a round over bit. It's an 1/8 inch round over bit. Let's turn that off. And we go around that, and that creates that softened corner. So this actually has 4 different tools. Now when you do the simulation, the facing won't show up because it's 0 depth. I'm just taking off material that was above 1.75. So let's go to simulation and see what happens. Okay, so we'll turn all this stuff off. The first thing, we're going to face it. Like I say, you're not going to see it because the material's already to thickness. We're just cutting what's at the top. There's the first pocket. All right, here are the pins. So there's the 2 holes for the pins. This is where we cut the outline. Now when I cut the outline, I did something different. I left 40 thousandths of material, and here's why. When I flip it over, if I don't get it perfect, and I want it to be a little fat, and then I'll do the final perimeter pass from the top. And if I don't get it perfect, that gives me some fudge room. Typically it doesn't require it, but I'm just planning ahead. And then this is a round over. It's hard to see on here, but it's an 1/8 of an inch round over that goes around that perimeter, because that's what was really on the model. Now, you may do different things there. There are other techniques that they use in guitar making where they put different strips of stuff. In our case, we're just going to we're softening it. You could actually soften it with sandpaper if you wanted to. Now I want to show you a neat feature. We've just added this to these controllers. It's a firmware and software upgrade, but basically now we've always been able to plug a USB key and operate the machine. And there's an internal memory built in the controller. It's about 500 megs, so it's almost a half a gig. But now I can plug this into my laptop, and it shows up as a drive, and then I just drag files over. And so it really works out well. It's a great way, if you've got lots of files, let's say you're making a set of kitchen cabinets with 15 or 20 sheets, it's a really neat way to do this. To start with, I've got this nice piece of mahogany that I made, and I put some double stick tape on it. If you've watched some of our other videos, you know I like double stick tape. And I'm simply going to try to get it lined up. And that looks pretty good. Okay, that's good. Now, so you see what I did? I used that perimeter cut so I would know where to line this up. And my blank is bigger than the bounding box, so I knew it would work. Let me tell you a little tip of how I created this block. I glued it together, and then I attached it to the table with tape, and then I used a tool to fly cut it. So it became my planer. So if you notice, I machined the top and bottom and all 4 sides of that. So just think about being able to do that with your machine. Okay, we've got our materials secured to the machine. We're ready to go there. Now let's talk about putting tools in and tool touch off. Now, like I say, we basically created this design based on our Smart Shop 1 dust hood with a little door. It's worked really well. Right? And that works really nice and it's accessible, but I think for shooting a video we're better off to take that off so that you can actually see what's going on. I think the first operation we'll do is to face the top of this so that it perfectly lines up with our setup. So what I've done is I've got a 1/2-inch collet and a collet nut. I'm going to put that in the spindle and tighten the tool. This is a puck system we use for tool touch-off. It's really neat. I like it because the new versions now, it completely comes off the machine. So you have a plug that plugs in here, and then you position it under the tool. And if I were touching off to the top of the material, I would set it here. In our case, this is actually, you can't really see it, but this is an area that was pocketed when I pocketed that area. So that's the same height as the bottom. And then all we do is hit 2 buttons. The machine comes down. You can always see the dimensions changing. And then it'll come down and make contact, and the tool's touched off. That's all you have to do. And then once it makes contact, it'll retract. It'll retract. The tool's touched off. As we go through these processes, I want to stop and explain a couple fundamentals because they apply to a lot of different applications here. But if you remember on the drawing, I showed you where X0, Y0 was, and it's basically in the middle. Well, let's send the machine to the origin and verify that's where it is. Okay, so the origin is wherever X0, Y0 is set, and I basically drew diagonals on the panel and set it that way. So that just verified everything's right. Now we're ready to run the program. Once again, if I had dust collection, I'd turn the dust collector on. I'm going to actually stand over here with the blower so you can really see what the cut is. This is the electrical panel. All the components are in here. It's air cooled. What you see here is a display for the spindle, and basically it tells you what RPMs the spindle's running at. So I can adjust it in increments of 60 RPMs if I want to. This just turns it on and off. This is an emergency stop. This is a disconnect. So this basically disconnects the machine from power. Okay, everything's set. We're ready to run something, so I'm going to select the program from the internal, and the name of the program is Facing, and it looks pretty good to me. Spindle's turning on. Okay, all right, yeah, just right. I'm changing tools to run the next program. We're going to touch it off. We're going to drill our pinholes. Well, we're going to change tools again. So we'll take that tool out. Okay, we're going to put the 1/2-inch straight tool in, and we're going to cut these pockets out, and then we're also going to cut the perimeter channel. Okay, time to touch off. Okay, now we got while we've got the 1/2" tool in, let's run the other program that uses it. Let's run the outline. Here goes. Okay, here's something that's kind of neat. You might recognize this as a standard router bit that you'd use with a hand router. I took the bearing off. What I really want is this is an 1/8" radius. That's the cutting edge I want. And that's actually going to go around there. So sometimes you got to think outside of the box. Now we'll put that tool in. Oh, the round over looks real consistent all the way around here, and that's because we fly cut. That's one of the reasons we did that. And there's a little ledge here, but remember this outside's still 40 thousandths fat, so it looks good to me. Okay, we've got the bottom side of that base piece machine, so that came out pretty good. Now let's go back and look at the 3D model and see what we have to do when we flip it over. So this is the top side of it. You can see on the screen here. Now, what we did earlier was we basically cut this out, cut the shape out, put the round over on it, and cut this pocket here. And we did that because those have to be accessed from underneath. Now we're going to turn it upside down. We're going to line it on pins to keep the front and back aligned. Now here's what we need to cut. We need to cut this. Whoops, wrong button. We need to cut this pocket, and it goes almost, it actually doesn't go through, but it intersects the other pocket. We need to cut this slot, and then we need to cut this hole here. The rest of these recesses get cut once the cap's on there. So basically that's what we've done. I created, once again, went in there and found the geometry and created a drawing. And then that drawing was, that's where the geometry came from for tool pathing. All right, in other words, here's our center line. We made sure that was right. All right, I brought that geometry into a spire, and there it is. And let's turn that off. So basically what's going to happen is you're going to have this tool path, and you see there, that's just going to pocket that out, and then same thing on these pockets. Now we're going to use a different tool this time, and I'll show it to you when we get up to the machine, but it's a real long tool. It's made by Vortex. It's for deep machining. It's 3/8 in diameter. The cutting edge is about an inch long, and then it gets smaller above that, so you don't get the heat from rubbing the side of the bit. So that's what we're going to do with these. Okay, now we've taken this off. We've taped the underside and put the pins in, and we're going to see if I can fill those holes. There's one of them. There we go. We pound on that tape to stick it down, and now we're lined up and should be good. Now I want to show you something while we're close in here. This is a bit I discovered at Vortex. Actually, I found this bit back when we did that first guitar video, but I call it a deep pocket bit. If you know, it's a 3/8 shank. It's long. If you notice right here, there's about a 1-inch cutting edge here, and then it gets smaller behind that, so you don't get the burning down here. Now we're going to take fairly shallow passes because that's a real long bit, and it'll make a lot of noise, so we don't. So that's what we're going to put in the machine. the machining for this base part is pretty much done. Of course, we did the underside first, and these pockets came out real nice. I think this is a slot in here for wires to run. Now the next step then is to take this maple cap, we'll glue it on, reintroduce it to the machine, and now we'll cut the 3D surface, and then finally we'll trim the outside of it. There's a couple pockets also left to be machined that actually go through this down into the base part, but we're getting there. Okay, well, we've got our piece of maple glued on now, and now it's time to get serious and talk about 3D. Okay, let's review so far what we've done in terms of programming. If you recall, we started with this model that was downloaded. It's a Les Paul style guitar. And pretty much what you see on the screen here is what we've machined, at least everything that has to be machined at this stage. We machine the back, we put that little rounder over the edge. You see the pockets. Now the only thing we had to machine on this side at this time was this slot here, because the rest of that's going to get done. But pretty much this is what's called 2.5D machining, which means a shape at a certain depth. Everything we've done here so far I could have done with VCarve Pro or simple software. It's nothing 3D yet, but it's coming. Now, so the next step is to create the top, and so we'll just turn that on. I've got that turned on where you can see it, and when you look at the guitar you'll see there's the surface, and this curved top is a surface. Now you may not be familiar with the term surface. It's an easy way to understand it is to think of something I have to cut out with a round tool. So for instance, if it's an irregular shaped surface, I'm going to use a tool that's round at the end. In our case it's called a ball nose. Now the amount of detail determines what size ball you use. Obviously the larger ball takes less time to machine, but sometimes if you're doing decorative stuff it takes a very small detail tool. In our case this is a gentle surface, so we're probably going to use a 1/2-inch tool. So that's how that's going to be created. There's also another 3D surface, and I didn't notice it at the beginning, but there is. And if you look down inside of here where the neck sits in that pocket, that's actually an inclined surface, so technically that's a 3D surface also. I can't cut that by saying cut this shape a certain depth. It only cuts it flat at the bottom. And so we'll have to deal with that. Okay, now let's take a look at this and let's see what we're actually going to have to do with this surface. Now first off, let's get rid of the body. Let's turn that off. So this is the top part. This is what we're really going to machine. So there's the surface part, and then you notice there's also some other cutouts here. And those are actually driven from shapes down below. Those are actually recesses that are created for the contacts and the pickups on the guitar. So we'll cut those all in one pass. And then you notice there's some holes here that have to be machined. There's 4 here, and they correspond to that underneath there. And there's a hole here, and I assume that's for a shaft. Okay, so now here's our problem though. There's an oh by the way in this. Let's turn this back off, and that is, if I try to cut that surface, the tool drops down in those holes. So I have to figure a way around that. Let's look at a solution to this. Okay, now what we've got here, this is just the top separated out. Now you see these holes here. I've actually on a layer, I've got patches, and you see these basically fill those up. In fact, if we render this, it's probably going to be easier to see. See how that? Because all I need for a spire is a smooth surface. Remember, those cutouts are 2.5D machining. So all I really need is a file for a spire that's got that smooth surface. And you'll see one other thing that I added in, and that is this plane down here. Now, you might wonder, why did you do that? Well, here's why I did it. Because I need a way to line this thing up. Because remember, everything has to be lined. The center line is in the middle. And we started out with what size the blank was and how the body fit in it. So I need some way of making sure that alignment carries through the spire. So when I bring this 3D surface in, it's aligned. And so that's why you see that plane. So all I did was took a surface. I took this surface, and then I actually made a surface out of this, and I exported those just as a 3D surface as a Rhino file of which a spire can open. Let's pretend we were doing a new job set up here. I want you to understand how you bring the 3D stuff into a spire. Sometimes it's confusing. All right, first off, I said, okay, my table or whatever this is, or block or whatever you want to call it, is 24 by 36. the material thickness, and that's the thickness of that glued up block, that's really what I'm looking at, is 2.5625, which is 2 9/16. All right, the origin is in the center, so the X0, Y0 is in the center. We're touching off at the bottom, and that allows us to use our tool touch off, so we'll say okay. Now what I need to do is I need to bring that 3D surface into a spiral so that I can tool path it. And here's how you do it. You go to the modeling tab, come up here at the top to where it says modeling tools, import a component or 3D model. Okay, aspire surface. Click on that. That's what I created. That's what it looks like. So it brings it in just like that. I'm going to accept it. I'm not going to change anything about it. Hit OK. Now that's how that fits into the material. All right. Now you see what you really see here is you see that 3D surface and you see that flat plane underneath. So that gives me the ability to locate it. And unfortunately it's centered, so I don't really have to worry about that. Okay, but now there's another step here that's involved when you mess with 3D, and that's this. Where within our volume of material does that rest? So we come over here to setup, and you'll see this is showing us where the model is. If you watch, it'll move it up and down. You'll see it move up and down within the volume of material. Okay, well, where do we want that? Well, I don't want it flush with the back. I actually want it, since my actual finished guitar's about 2.46, I really want this thickness here. I really actually want this from the top point 0.0945. That's the number I need. Okay, when I put it in there, when I'm finished with the guitar, it is the correct thickness. So that's why you go through that. And that's sometimes the confusing part of doing 3D stuff. Because we're doing two things with Aspire. We're going to tool path that model, but everything else we're doing from geometry. So in addition to that model, I also need the DXFs that line up with that. So that's where we're going to go next. Okay, now that you understand where the 3D surface came from, let's talk about a strategy of how we would actually machine this. Now, there is one step you could add to it that we're not going to do that you could, and that is you could actually fly cut the top of that glued on piece. If you did that, that gives you the ability to flip that over just in case you forgot to machine something on the back. We're not going to need to be able to do that, hopefully, but if you ever wanted to, if you fly cut that, you could actually fly cut that and drill your pinholes and locate it. So just keep that in mind. What I think I want to do first, though, is I want to kind of define the perimeter of the edges of that surface. And the reason I'm doing that is so when the ball tool gets over to the edge, it doesn't slam up against the material, and that'll make more sense to you. So I'm going to call this surf edge. There's the tool path. And let's look at the simulation, and you'll be able to see what it does. Reset that. Oops. So that's what's going to happen. The tool's going to go around. What I've really done is taken the outside shape and offset it, so it's really it's about 5/8 wide, and I'm taking a smaller tool that's a long tool and just cutting that out. And what that's going to do is that's going to give me a nice perimeter around there. Later I'll use that same tool or that area to cut all the way through to separate the pieces, but at this point I'm really just trying to define the edge of where that surface is going to end up. Okay, now let's talk about how you tool path the 3D surface. We already talked about the fact that you have to use a round nose tool. Typically we do two passes. One is a rough pass, and we typically take quite a bit of material off. We do it in steps, and we do it in steps this way, so that we typically might make a path and offset that path 50% of the tool diameter. So if you use a 1/2 inch tool, it steps over, that's what it's called, a step over, a 1/4 inch. And our whole intent here is to just get rid of material. And we'll leave a margin on top of the surface, maybe 40 thousandths. So that's the rough pass. Once that's done, then we do a finish pass. We're going to use the same tool. The only difference is it's going to come in and the step over is going to be about 10%. So it's going to leave a much smoother surface. So remember, rough pass, then finish pass. Okay, now let's look at the simulation on the software here so you can kind of get an idea of what's going to happen. The first thing I'm going to click is the rough pass, and we hit preview, and what you see there is what's going to happen on the machine. It's doing it in steps, and if you notice there's pretty good waves there. That's that 50% step over. But the point of that is to get a lot of the material away, and I told it to leave 40 thousandths above the surface. All right, once that's done, then we come back over and we do this finish pass, and that's what makes it smooth. And now that's a 10% step over, and you see it's a much, much smoother surface. And once that's done, that's pretty much that part of the 3D surfacing. That looks pretty good. Now we're beginning to see the shape of the guitar. And that gives us some recess so that when we do our 3D surface here, it'll have a nice edge on there. So that looks good. Let's go to the next step. Okay, we've changed tools. Now we have the 1/2" ball nose tool we talked about. And now this should do the roughing. I paused the program and turned the spindle off because I wanted to point something out to you. You see these terraces? That was the rough pass. Okay, you see these waves here, that's the 50% step over, and the depth per pass is about 1/8 of an inch. So that's what you're seeing here. So it calculated all the material that it had to get rid of, and I told it to leave 40 thousandths of material across the surface, above the surface. So now I'm going to turn the spindle back on, start the machine back up, and now it's going to go around and it's going to create that smooth, that final surface that we're really looking for. All right, this is my favorite time. Let's see what we got here. There is something really unique about 3D. It's almost like this part was hiding in that block of wood all the time. I just didn't know it until I cut it. That's so neat. Now you see the curvature, you see how this corresponds to what we looked at on the computer. This is that surface. Now what we'll do next is we'll come in and we'll do the machining in that surface. Okay, let's take a minute and review the software. Let's see what we just finished, okay? The first thing we did was we actually cut the perimeter. So it defined the perimeter and gave some clearance for the edge of the ball tool. Okay, then we put the ball tool in and we did our roughing pass and we looked at those terraces after that completed. And what you just saw was the 3D finish. And that's what really produces the final shape, the final surface. Like I said, it's just magic when that appears. Okay, now where do we go from here? There's actually a little bit more 3D machining, but that's not what we're going to do next. Now we're going to machine some of the electrical stuff. So there's 1, 2, 3, 4. I call those deep pockets. Then there's some shallower cutouts that also go there. Now what's amazing, when we get all this done, this will all be interconnected with the machining we did on the base part. It's incredible when you see this. So, and then also we have some holes here, and we're going to machine those also. And these correspond with cavities that were machined on the underside. So all of these are done with the same tool. So even though it's multiple operations, that will create one program with that tool. So let's get started here, and we'll get that program over to the machine. I want zero gap at the bottom. In other words, the way I created that surface plane is at the very bottom. So I have to make that change, and it's going to tell me to recalculate tool paths. So now that surface, that plane is flat against the bottom. Now we can create our tool paths. And then it's just a matter then of identifying, here's our neck pocket, here's what it's going to look like. So what we'll do is, that's highlighted, we'll open that up and we'll recalculate that. And now we'll reset our preview. And on the machine, that's what's going to happen. It's going to cut that out. Then we've got the same token, we're going to come over here, we're going to do the 3D surface of that. We'll open that. That's selected, that surface, we'll calculate that. And we'll preview that. And that creates a bottom. So you've got, just like we did at the top, it's a rough surface, and then we have a finished surface. And the rough surface basically removes the material for the pocket, and the finished surface takes care of that slide angle. And you'll be able to see it when it's running. Okay, now it's getting positioned. If you watch, it's just going to pocket out. It's going to move over to the next position. It's going to step down an 1/8 of an inch each time. Even though I'm using a straight bit, it's the same process we use when we do the top. It's just we're making a rough pass, and it's doing it with a straight router bit, and it's compensating for that. Everything's come out very well. Now it's time to actually do the perimeter. So what we're going to do first is cut through this material. That separates the guitar body from the rest of the blank. We're going to take the corner pieces off the blank and get them out of the way. Then we're going to come in where we have good access to that entire edge and do a real nice edge finish job on there. Remember, we're still 40 thousandths oversized, so we've got some room to play with. Finish one. Rock and roll. All right, let's see what we've got. Wow, we've got a guitar body. Man, that's incredible. Now I see how all that fit together. I can see where that groove that we put on the top of the bass one connects. Wow. Huh. There's a surface, we turn it over, and there's the holes line up. These holes line up with those cavities. That's incredible. Oh, look at this. Here's that inclined surface, because the neck on the guitar has an incline on it, so we had to have it. That's that 3D surface that we created. That came out really nice. Wow. I like that mahogany too. It looks good. You know, I really enjoyed doing this Les Paul style guitar project. You know, there's something very therapeutic about woodworking in general, and it's also the same. I found it the same way with CNC. It's not so much how a tool feels against the wood, it's about how you design something and you see it happen in front of you. It's really the same thing. Well, I hope you enjoyed the video. We certainly enjoyed producing it for you. If you need more information about the Laguna IQ, CNC, or any other Laguna tool, call us at 800-234-1976. You can also check us out on the internet at lagunatools.com. And I'd invite you also, if you have an interest in this, to participate in our Laguna CNC forum. If you have any questions about this specific demonstration, just post them there and we'll try to answer them for you. Thanks for watching.